Hello everyone, good morning. I'm Javelin and the topic that I'm going to discuss today is about electrical safety. Electrical safety is closely related to fire safety, so we hope you do not mind hearing some things twice. Fires are often caused by electrical trouble, as we all know, although we also know that electrical trouble can be also mean other things like electrocution and other such accidents. This module aims to introduce you to the basic terms in electricity, occurrence mechanism of electrical shock accidents, and preventive measures for electrical shock. We already know that electrical safety has to do with understanding voltage, current, and resistance. You and all the other people in the workplace must understand electrical safety in order to prevent accidents, injuries, death, property damage. Unsafe practices related to electricity might adverse effects to the human body and property and are the primary causes of fire. There are practical measures that you can follow to ensure electrical safety. Objective: define the basic term in electricity. Describe the danger of electric shock. Identify the practical measures in preventing electric shock accidents. Electricity is essential and considered as among the basic needs of everybody. Electricity had made our houses into homes, changed the mode of transportation from calesas into taxis and metro railway transport system or MRTs, and improved shops to malls and factories. It is hard to imagine if we had no electricity until now. However, it is also among the common causes of occupational accidents resulting to injuries, death, and property damage. More than 1,000 workers are killed each year by electrical shock and thousands more are burned or maimed. More than 90% of the fatalities occurred when a person who was grounded made contact with live wire or an energized equipment housing line-to-line. Contact accounted for fewer than 10% of the death. Electrical safety requires understanding of what electricity is, how electrical energy is transferred, and how the path through which electrical current travels can be controlled. Electricity can be defined as the electrons along a conductor. Electrons are negatively charged particles distributed in orbits around the nuclei of atoms, which are the smallest units of an element that can exist either alone or combination. In an atom, the negative charge of the electrons is neutralized by the positive charge of the particles, called protons, so that the atom is electrically neutral. If an external force is applied so that the electrons are removed from their orbit and directed to a given direction, electric current is produced in that direction. Electrical current requires a suitable circuit to provide energy needed for lighting, heating, and etc. An electrical circuit usually contains a power source and an electrical load. Suitable conducting material connects the power source to the load in order to complete the electrical circuit. These conductors are covered with a suitable insulating material to prevent the current from leaking out. Some materials, such as metals, have closely bounded electrons, and thus amount of thermal energy available at room temperature is sufficient to generate free electrons. These are the materials. Materials that have a relatively charged number of free electrons at the room temperature is called conductor. Materials that do not have a large number of free electrons at room temperature, such as plastics, is called insulator. Materials that fall in between the two extremes is called semiconductor. Elements of electricity. Voltage. In order for electrons to move between 2 points, a potential difference must exist. The potential difference between 2 points in a circuit is measured in terms of volts. The higher the potential difference, the easier it is for the electrons to move from one point to another, and the higher the electric current. Resistance. The flow of electrons is also governed by the resistance offered by the conducting materials. It is measured in ohms. Current. The current flow in a circuit is measured in terms of amperes. 1 ampere, by definition, is the flow of 6.8 times 10 to the power of 18 electrons per second pass a given point in a circuit. Sometimes it is necessary to use smaller units of measurement for the current flow, the most commonly used units being the milliampere. Water and electricity in water analogy. Hydraulic pressure is like voltage. The greater the hydraulic pressure, the greater the flow of water through the pipe. Pipe resistance is similar to electrical resistance. The greater the resistance, the lesser the flow of water. Hazards of electricity. Electrical shock, burns, and fire. Electrical shock occurrence. Electrical shock is a common hazard encountered by people involved in the installation, maintenance, and operation of electrical equipment. Electric shock occurs once the worker body becomes part of an electrical circuit, when it comes in contact with a live internal conductor at the point of insulator breakdown. The more common sources of electrical shock are refrigerators and electric fans. The defective and poorly maintained electrical device will generate electrical leak. Below are the common causes of electrical injuries or accidents. Touching of the live parts. Next is short circuit, inadequate guarding, overloading, and the last is breaking of connections. Factors affecting the electric shock. Amount of current that flows through the human body, the amount of current that flows to the body depends on voltage of the circuit, or according to Ohm's law, the voltage is directly proportional to the current. A higher voltage means a higher amount of current. Insulating quality. Number 2, the path current takes through the body affects the degree of injury. A small current that passes from one hand to another hand through the heart is capable of causing severe injury or death. However, there have been cases where larger currents cause an arm or leg to burn off without going through the vital signs of the body. In many such cases, the person was not killed had the same current pass through the vital organs of the body. The person easily could have been electrocuted. Duration of current flow. The longer the current flows through the body, the more devastating the result can be. That is the reason why immediate action should be taken to free co-workers when they are shocked or burned by electricity. Action to take. Shut off the electric current if the victim is still in contact with the energized circuit. While you do this, have someone else call for help. If you cannot quickly get to the electrical disconnect to turn off the current, pry the victim from the circuit with something that does not contact electricity, such as dry wood broomstick. Do not touch the victim yourself if he or she is still in contact with electric circuit. You will become a victim of electric shock. Number 4, types of electric energy involved. Alternating current or AC, the flow of electric charge whose magnitude and direction changes periodically. This can cause a person to maintain an involuntary grip on the live metal or conductor and prolong the current flow. Direct current or DC, the flow of electric charge that does not change direction. Body condition is personal sensitivity to electric shock varies with age, sex, heart conditions, or etc. An electrical current passing through the body can cause severe injury or death by contracting the chest muscles, resulting in breathing difficulty and death due to asphyxiation, affecting the central nervous system, resulting in malfunction of vital body functions such as respiration, interference with the normal rhythm of the heartbeat, resulting in ventricular fibrillation, which is defined as very rapid, uncoordinated contractions of the ventricles of the heart, resulting in loss of synchronization between heartbeat and pulse beat. Once ventricular fibrillation occurs, it will continue and death will ensue between a few minutes. Electricity may also affect the heart muscle, resulting in severe heart muscle contraction and cessation of heart action. Heat generated when current overcomes tissue to resistance. The severity of electric shock is the product of the current value and the time flows through the body. And that's the end of my discussion, and the continuation of this topic will be tackled by Mr. Gonzaga. Thank you.